Welcome back to Educator.com. In this lesson, we're going to take a look at some polynomial inequalities. Now, when it comes to polynomial inequalities, I'm going to show you two techniques that you can really use to handle these. One, you can take a look at their graph and really figure out where they're greater than or equal to 0, or you can use the table to really track down their sign. So both of these are important, and since we have developed lots of graphing techniques, they are both very handy. So a polynomial inequality is simply an inequality involving a polynomial of some sort. And down below I have many different examples of what I'm talking about. Here's a nice, negative 2x to the fourth minus x squared minus 2 is greater than 4. That'd be an example of something we're trying to solve. Same thing with this one, like 8x cubed plus 2x squared less than 6x plus 5. Another good type of inequality that we could possibly find the solution to. Now, depending on the type of polynomial present, sometimes you can call these linear inequalities, quadratic inequalities, or even cubic inequalities. But I won't get too technical. Usually we'll just call these like polynomial inequalities. Now, to solve one of these inequalities, it's best to get it in relation to 0. That means get everything over onto one side of your inequality symbol. The reason why this is so important for the entire solving process is we're looking for those ranges of values that make the inequality true. And when it's all in relation to 0, then we really just have to know where is it going to be positive or negative, rather than trying to search for, when is it greater than or less than some other number like 2 or 3, and that's much more difficult to do. Now, if you have a graph of the polynomial, this makes it especially easy because then you're essentially looking at whether it is above or below the x-axis. Let's take a linear equality like this. So we might know where it crosses the x-axis. Everywhere where it's above the x-axis, we know it's positive. And everywhere below the x-axis, we know the value is negative. So if I had the equation for this, and maybe I wanted to know where it was greater than 0, then I could simply take all of the positive values where it's greater than the x-axis. Let's try a quick example to see this in action. So I want to use the graph of x squared minus 3x minus 4 to see where it is greater than 0. So it's already set in relation to 0 for us. We don't have to do any work there. I just need a really good rough sketch of what this looks like. Well, I could figure out where this thing is equal to 0 by using some of our factoring techniques. So our first terms better be x, and then a minus 4 and a plus 1 will do fine. So I know it crosses the x-axis at a positive 4 and a negative 1. Now, since we've also done a lot with graphing quadratics like this one, we know which direction it's facing. The a value is positive, so it is facing up. Let's see, what else do we know about this? Oh, it looks like it has a y-intercept of a negative 4. So let's put that in there. Alright, so a rough sketch of this might look something like that. And you'll note that I didn't go through all of the work to find the vertex, because I'm not really interested where it reaches its maximum or minimum value. I'm really just interested where is it above or below the x-axis. Alright. So for this particular polynomial, we want to know where it is greater than 0. That's a way of saying, where does it take on positive values? Well, we can see that it really does this after the value of 4, and it does it before the value of negative 1. So in those intervals, if you're using, say, those x values, then the equation will be positive. So we'll take those intervals as our solution. From negative infinity up to negative 1, and from 4 up to infinity. So that really grabs up both of those intervals. We'll use our little union symbol in between to show that it could be in either one of those. Not bad.